Dear ladies and gentlemen, I welcome you on behalf of the AUTOSAR Steering Committee to the AUTOSAR Release Event 2022. My name is Günter Reichhardt and I am the current AUTOSAR spokesperson for Europe and the moderator of this event. The corona crisis, fortunately, seems to lose its high impact, but most of us are meanwhile well accustomed to virtual meetings and to home office work. Thus, you will have no problems with our virtual release event. I'm pretty sure that you will gain a lot of insights on the progress of the AUTOSAR standard. There will be opportunity to raise questions or to comment the presentations in a Q&A session afterwards. So please use the opportunity to use the chat function to raise your questions which might come up during the presentations. Despite of the impact of the corona pandemic, we are proud to present the many achievements which the AUTOSAR Consortium has made, and I would like to thank all partners and experts which have contributed to this big step forward. The AUTOSAR mission is to develop and establish the standardized software framework and open E/E system architecture for intelligent mobility in a global partnership of leading companies in the automotive and software industry. To achieve this, AUTOSAR has to deliver the software framework in time and quality. Continuous improvements and new features as an answer to upcoming requests are a key for our future success. Openness to collaboration with third-party organizations will also guarantee that AUTOSAR will deliver with its two platforms the decisive building blocks for future vehicle systems. The classical platform is already in widespread use, and its continuous update is based on this worldwide experience and your feedback out of practical application. The new adaptive platform has already found its first serious projects by some OEMs, and I am absolutely sure that it will become the same success like the classical platform. The compatibility of the two approaches and their common elements as part of the foundation form an excellent base to reach our vision. AUTOSAR will be the global established standard for software and methodology, enabling open E/E system architectures for future mobility, supporting high levels of dependability, especially safety and security. As most of you know, AUTOSAR is not a classical standard with just paper documentation. Instead, it is a living standardization with continuous quality improvements and feature enrichment. The release event is every year dedicated to present the results of this continuous effort to enrich and improve the AUTOSAR standard to partners and non-partners. Let's come now to the agenda. What we will present in the next hours is an introduction of the new releases and their relation to the classical platform and adaptive platform of AUTOSAR, as well as to foundation and methodology. Nadim Salem, the technical manager of the adaptive platform, and Jan Hegewald, the current PL speaker, will give an introduction to AUTOSAR with a focus on code and quality. After his introductions, they will have three presentations which will explain the releases in detail. The topics are timing analysis, in-vehicle communication, and first speaker will be Rudolf Diensbeck. Then we will have Richard Huber and Oliver Garnatz. After them, Rinat Asmus and Jan Hegewald will follow these speakers with an outline on the opening strategy of AUTOSAR. Rinat Asmus will continue with a glimpse on AUTOSAR's planned progress in 2023. Afterwards, we offer you a Q&A session in which you can raise your questions and our speakers will answer these. We will conclude with a networking session in which you can get in contact with the speakers and with colleagues. Please use this hour to bring your views and comments on the table and have fruitful discussions with the experts. Now I would like to hand over to Jan and Nadim to give us an introduction into AUTOSAR.
Thanks a lot, Günther, for this kind introduction, and definitely we'd like to take the chance to no audio. We'd like to take the chance to give you an introduction into AUTOSAR itself, but also into what we have been releasing in 22-11. I'd like to start with an overview over AUTOSAR and what AUTOSAR means in the end. So let me start with the global AUTOSAR mission. So we are a global partnership of leading companies in not only the automotive industry, but also the software industry. And our goal is to standardize a software framework and an open EE system architecture. This is all to facilitate intelligent mobility, to facilitate innovation in the end. And I think that in the end, this is really strengthened by the citation of Günther that's also on that slide here. If a company develops alone, it will be a proprietary solution. If it is shared and used by several partners, it becomes technology. And with broad standardization, like in AUTOSAR, it becomes state-of-the-art and alleviates certification. So it's not only about the innovation that we allow, but also with strengthened certification, we allow certification. And we can only do that with our partners. Together with our partners, we form the AUTOSAR community. And even though AUTOSAR has been founded by the core partners and is steered by the core partners, all the premium and development partners you see on that slide, and those are even more today, those are developing the standard together with us and bringing in their requirements to further the standard. So we're looking forward to even more than 350 partners at the beginning of next year, and all these partners together form the standard. But what is the standard? So what are the basic principles? In the end, it's all about reusability and exchangeability. We allow exchangeability between different supplier solutions. We allow exchangeability between vehicle platforms. So this is also for OEMs. And we allow exchangeability between manufacturers' applications. And this means that there are facilities within AUTOSAR that really ease the collaboration between different partners in the industry, and that allow reuse of software modules, but also to exchange software modules between those different partners. And these are, for example, OEMs, suppliers, software developers, and so on. But how do we now organize all this work? Let's take a look from top and then go a bit more into the detail afterwards. What we see here is basically the AUTOSAR organization really looking from the top. We've got some governance structure here, some strategic management with the executive board and the steering committee, which is also facilitated by different other teams like the legal team and communication team dealing with all the efforts, for example, for this release event and allowing us to present AUTOSAR in the world. We then have the project leader team, which is the connection between strategic management and the standardization in the end. So project leader team, where I also am a member of, does the technical steering of the standards that AUTOSAR releases and works together with the working groups and steers them. So in the end, the real standardization work, the technical work, is done in the working groups. This is where people bring in their views into the standard, where people discuss and in the end write the standard together with many, many others. And this is the next view we will see. So what are those working groups? The working groups in AUTOSAR are structured in different categories here. So what you can see is a big block of cross-standard working groups. What does this mean? AUTOSAR releases currently 3 standards: the Adaptive Platform, Classic Platform, and Foundation. We will see later on what this means. And cross-standard working groups means that those working groups really focus not only on one standard, but they have the whole standardization landscape in view and provide solutions for the whole standard that AUTOSAR releases. And then within those cross-standard working groups, we're, for example, talking about lead working groups that deal with architecture, so the architecture of our platforms, that deal with methodology and templates, so looking into how can we ensure that collaboration within the industry really works and provide the proper methodology, but also the proper file formats and description formats to work together. Last but not least, we've got security and safety. So automotive security, cyber security, and on the other hand, safety in the lean groups, which are 2 important pillars of AUTOSAR. So these are really things that, like said in the beginning, alleviate certification and allow us to provide platforms that are usable in all our cars. And then there are those more like technical working groups dealing with different topics. So for example, we've got a working group for in-vehicle communication, we've got one for diagnostics, and those are the places where the topic-wise discussions happen and where things are then standardized. Below that, you also see platform-specific working groups. So for example, for the classic platform, we've got certain specifics that are only relevant for this very platform, and those are then discussed in those other working groups, as well as on the adaptive platform side. You also have working groups that, for example, deal with coding, which is something that's unique for the adaptive platform. But why do we do all that? This is because of the complexity increase within the automotive industry and the software that's around it. So when we started to see ECUs, distributed ECUs arise in the 1970s, we had little software, little interconnection. And all this increased until now, when we see the zone architectures emerging in the automotive industry, and all that needs some kind of standard, some kind of basis you can develop upon and innovate upon. The next step definitely is the software-defined vehicle. We all see it emerging across the board with different organizations, and this is definitely something where AUTOSAR would like to and will play a role, but where we also need to see how we work together with other organizations. So this is nothing AUTOSAR can do alone, but we need to work together. And this is where we have a kind of meta standardization, so to say. We are working together with other standardization organizations and other bodies to come to a conclusion: what is a software-defined vehicle, and how can we elaborate it best to make use within the industry. I already briefly mentioned the platforms that AUTOSAR currently standardizes, and here you see how they could interact. So for example, in the middle, you've got a vehicle that uses the AUTOSAR Classic platform, uses AUTOSAR Adaptive platform, but may also use non-AUTOSAR basic software, which are all interconnected via a communication network. And this communication network, for example, could speak some IP. Some IP is a protocol that's standardized within AUTOSAR and allows the connection of different ECUs on one bus, on one communication network, and allows all those ECUs to talk together and to find the best solution how to do it. So what is the classic platform? It basically is formed out of 4 pillars. We've got the functional safety pillar, which is really important for the classic platform because the classic platform is something we're using on highly embedded microcontrollers. And as such, we definitely need those functional safety mechanisms up to ASIL-D, but it's also capable of using it in a QM environment. We've got the efficiency pillar, meaning that we have different stack vendors implementing the standard and then allowing the users of the standard to choose which one is the best and which fits best to their use case. It's field proven, so the classic platform is the standard of AUTOSAR that's around the market for a long time now. And AUTOSAR will have its 20th anniversary next year, and this is really something which is built also on the classic platform. And then there's the performance point. So with the classic platform, we are able to provide hard real-time capabilities, and this is essentially essential for those ECUs where classic platform is used. The adaptive platform, on the other hand, still features safety and security. That's definitely important to fulfill all the use cases we see in the market and to allow usage of the adaptive platform, for example, in terms of in ADAS AD applications. And there you see some examples. So we've got external communication where we see the need for secure communication. We see in-vehicle communication with the secure onboard communication, for example. But we also have platform features that allow safe and secure handling of software, for example, the safe data storage. And then the adaptive platform is also connected. It's connected to the outside world, for example, to vehicle to cloud, vehicle to X applications, but it is as well also connected to the rest of the car, for example, via DDS, which is also a feature of the adaptive platform, and therefore could also interact with other base systems like ROS. It is as well dynamic and updatable, which is also a differentiation between adaptive and classic platform. So we get some mechanisms in the adaptive platform, like the update and configuration management, that allow us to update not only the adaptive platform itself via some software packages, but that can also, in the end, be used to update some classic platform ECUs that are in the same car and that can communicate with the adaptive platform ECU. So in a nutshell, what does this mean? For the adaptive platform, we have real-time requirements that can be fulfilled in the range of milliseconds. So it could be considered like a medium real-time requirements that can be fulfilled. For the classic platform, on the other hand, we can fulfill really high real-time requirements in the range of microseconds. In terms of safety criticality, we have the possibility to allow at least ASIL-B for adaptive platform, potentially more. That depends on also the microprocessor that's being used for adaptive platform. And for the classic platform, on the other hand, as already said, we've got really the highest safety criticality level that can be fulfilled with ASIL-D. And then on the adaptive platform, computing power is way higher than in the classic platform. Like in adaptive platform, for adaptive platform, we're usually using microprocessors that allow way higher computing power than microcontrollers that we use for the classic platform. And with that, I'd like to give it to Nadim, who will introduce you into what has been happening in 2211. And stage is yours, Nadim.
Thank you very much, Jan. My name is Nadim Salem. I'm the technical manager for the adaptive platform in AUTOSAR. And with this, I'd also like to have a warm welcome to all the listeners around the world. So this depicts now our AUTOSAR software framework, as we call it, with the platforms that you've heard a lot about already from Jan. Basically, on the on the lowest basis, we have the so-called foundation, which is a collection of specifications as a basis for the platforms on top, comprising, for example, of protocol specifications or other things that the classic and the adaptive platform then can make use of. Above that, we have the classic platform and the adaptive platform, making use of the foundation specifications, where Jan already said a lot about what these platforms are. One differentiation between classic and adaptive platform is that for the classic platform, we release the specifications, whereas the implementation is up to the market. On the adaptive platform side, we also release the so-called adaptive platform demonstrator, which you can make use of as a proof of concept and as a platform for our validation of the specifications. So there is code available for certain parts of the adaptive platform. If you want to have more details about this, feel free to look into the release overviews and the release notes of the demonstrator itself. On top of that, on the classic platform, we had in the past the acceptance tests. For the sake of completeness, they're still listed here, but they're discontinued. So for the 22-11 release, you will not even find them anymore. But in the past, we also had acceptance tests for classic platform. But what's still available and alive is the application interfaces and the sensor interfaces, where AUTOSAR standardizes certain interfaces for the applications to be used. So, for example, specific sensor interfaces or other application interfaces on both platforms. That being said, let's have a look at the 22-11 release and specifics. This is a list of the concepts. Also in AUTOSAR, we call them concepts, so the new features that have been introduced in our newly released R22-11. You can see the earlier depicted platforms here, Foundation, Classic, and Adaptive Platform, and the impact of those features onto the platform. So you can see that several of those features are cross-platform features which affect both platforms, because this is one of the key selling points from AUTOSAR, that these platforms are interoperable, and you can use ECUs of both platforms within the vehicle to communicate with each other through the defined protocols, for example. So on the one hand, we have inter-vehicle communication features, even combined with security, like the MACsec feature, which is a security protocol for the media access control layer. We have new bus systems like CAN-XL. We have firewalling to increase the security of the system. We have diagnostics topics, so the implementation of the SOVD standard into AUTOSAR. Whereas another new protocol, which is DDS support for classic platform, which has been introduced now. But also V2X, either on the one hand an AUTOSAR for classic platform, but on the other hand also the introduction of the Chinese V2X protocol into AUTOSAR. So throughout the world, there are different vehicle-to-X communication protocols available, and this is the feature that introduces the Chinese one into the AUTOSAR standard. On top of that, there were also some cleanup concepts in AUTOSAR, which harmonized the SAM-IP usage, for example, and as you can see on the right side, the adaptive platform demonstrator. And speaking of such, a short overview about the development of the adaptive platform demonstrator throughout time. Starting back in 2017, we had a very small introduction of the demonstrator with 400 something C++ files and like roughly 50,000 lines of code, whereas we're up to 330,000 lines of code now, which doesn't really say much about the features, but it gives you an idea of how much the demonstrator increased. And if you want to there, we have other notes available with the demonstrator, or feel free to contact me, of course. So looking at the validation that I mentioned, we are using the demonstrator to validate our specifications. What does that mean? You will find in the specifications two tags which are called valid and draft. And with this, we're depicting something on the one hand, how much quality assurance mechanisms we have put on these items. So if there was a dedicated validation, either by demonstrator or other means, of those specifications, then they're set to valid. If we have not done this yet, so it's an introduction of a new feature where this wasn't done yet, that doesn't mean we have not performed quality assurance mechanisms, of course. There are several throughout our processes, but this final validation has not taken place. And the main impact is our backward compatibility assurance, which says that for the valid items, we assure that we will keep them backward compatible if we see the need to change them, whereas for draft, there could be potentially incompatible changes in the future. Of course, AUTOSAR sees that the quality of the standard plays a very important role, especially for the implementers of the standard. And we are continuously increasing our efforts to hold the balance on the one hand, because we see the high need for new features in the standard. And on the other hand, of course, the need for quality of the standard. So what does 2211 in numbers mean? Well, we had more than 2,000 incorporation tasks in all three AUTOSAR standards. We had more than 1,400 discussed change requests in the community. 180 partners were collaborating in 20 different working groups together to achieve this goal of this release. And well, 334 and some more lines of code in adaptive platform have been written, not only in this release, but overall. Whereas 13 new concepts, that means the big features, have been introduced in adaptive classic platform to tackle the future goals. Well, 2 standardized AUTOSAR software platforms to use based on the foundation, and well, to define one holistic EE system architecture for future intelligent mobility. And with this, I'd like to hand over back to Günther and to the other presentations. Thank you very much.
Yeah, thank you, Nadim, and thank you, Jan, for your excellent and comprehensive introduction into AUTOSAR and the impressive overview on this year's release.